Hello friends, in this one I'm going to show you how to do a basic proof by contradiction. So here's the question. Prove that there's no smallest positive real number. That's a good enough statement for our purposes. Let's see what happens here. So we're going to do this by contradiction. That means the following. Assume the opposite. So first of all, assume the opposite of what? That's the first part, right? So this says there is no smallest positive real number. So assume the opposite, meaning that there is a smallest positive real number. And for the sake of having a symbol, call that number r. So down on the number line, what we were assuming is that here on the number line, say to the right of 0, there is a smallest positive number, call it r, in that position above my head. Now take a look. Notice that r, of course, can actually just be divided by 2. There's nothing special about dividing by 2, though, keep that in mind. It could be 4, 5, 10, whatever. Point is that if you have r, then r divided by 2 or 3 or 10 or 20 is a smaller value. So the point is that r over 2 in this particular case is less than r. So what is this telling us? What this is telling us is that the assumption that there's a smallest positive real number has been contradicted. So if you look at the number line, we're assuming that r is the smallest positive number, but then by simply dividing it by 2 or some other value like 10, we get r over 2, which is smaller. In other words, as you can see in the number line, it's closer to 0. In other words, this value r over 2 contradicts the assumption that r is the smallest positive number. So what you can then conclude is that there really is no smallest positive real number, because for every one that you propose is a positive smallest real number, you can always find one that's smaller, contradicting that assumption essentially. So for example, to be more concrete, if r is 6, and you pretend for a second you assume this is the smallest positive number, then you can just take 6 divided by 2 to get 3. Clearly 3 is smaller, isn't it? So that contradicts the assumption that 6 is the smallest number. In general, we use r, for example, and then like r divided by 2 or 10 or some value like that. And that's pretty much it. So thank you so much for watching. Please leave a like and subscribe. This is one of the most elementary examples of a proof by contradiction. I'll see you in another video.